Hello, everyone. You are welcome once again to today's lesson. And in today's lesson, we are going to continue from where we left off, okay, on lesson three. Okay, so in lesson three, we realized that we were dealing with what? Again, rational functions and partial fractions. Okay, but we looked at various situations, but all the rational functions that we were given, we've realized that so far, all were, what do you call it, proper. In today's lesson, we are going to look at how to resolve improper rational functions into what? Partial fractions. So please, stick and stay with me whilst I walk you through how to deal with this kind of situation. So our worked example 4 is all about what? The improper fraction resolution. So resolve the following into improper fractions. So you have how many? 1, 2, 3, 4, 5. 5 of them, but we'll do maximum 3. Okay, so these two will be yours, to try later. Obviously, once this is in green, you should know that you are likely to see it in the test. Okay, take note of that. So if you want to write it and practice later, you do so. Okay, so as usual, read questions, underline salient part, if any. Okay, so there is no salient part to underline. Usually you are asked to resolve into partial fraction. If you are asked to write the identity, then you underline the identity so that you don't go beyond. Okay, so now, after that, the first thing that you write is solution. Questions are numbered because we want you to number your solution. If it's not, they are not numbered, you shouldn't, number as well. So major question number is 4. Okay, then I'm going to deal with A. Given, the first one, you can choose not to, write the given, but this must be there. I always write given, So at this point, what do? We check, we ask ourselves that vital question. So the vital question, proper, improper, that's the first question. You realize the degree of numerator is 2, that of the denominator is 2. So we are dealing with what we call an improper rational function. An improper rational function, remember, when I introduce, you have to write the identity first whenever you are resolving. So if you don't know how to write the identity in a situation where your rational function is improper, then it means you cannot go forward. You cannot continue because it is your identity that you are going to use to find the letters that you introduce in your identity, and therefore you resolving the rational function into partial fraction. So you remember I gave you a hint, so I'm going back. So let me go back and see. So we are all going to look at, I remember I told you this when you were looking at expression, rational functions into partial fractions. I said this. If your rational functions is improper, so if it is proper, we said proceed to write the corresponding identity. However, if it is improper, remember here we didn't say proceed to write the identity. You cannot proceed straight away to write the identity. Therefore, you consider the denominator and move on. However, when you have this situation, first step, express your rational function, which is improper, in the form quotient plus remainder over divisor, and you can only do that when you do your long division. Then after that, what do? Take the proper fraction, and we all know how to resolve proper fraction, which is this part. Go and resolve into the corresponding, write the identity, then you resolve. So basically, write the improper fraction identity, take the proper fraction, go and write what the proper fraction, or resolve the proper fraction, and you are done. As simple as that. So now this is what we are going to do. The last step will be taken care of after finding the identity here. So in this case here, you end at the identity because we're looking at the identity. But what we are going to do will go beyond the identity. But if you don't know how to write the identity, then obviously, like I said, you cannot resolve. So first of all, let's go and look at how to get the identity in the situation of the improper. Then after that, we'll look at how to resolve. So quickly, this is what we are going to do. We need to first of all write this as a sum of the quotient plus a proper rational function. So on that note, we need to go and use our long division. So this is going to be equal to Okay, we need to go get our quotient plus the remainder over the divisor. And you can only do that when you perform the long division. So remember, okay, we need to set up our long division. Okay, your denominator, which is your divisor, is written out completely. You can see that, however, your numerator, which is your dividend, is not written out completely. So you know when you are setting up what I told you to consider when you were doing, okay, polynomials. So remember I told you closely linked. So which one is supposed to be here? Which one do I write here, my divisor or dividend? Before I bring my square roots or my roots, which will indicate the long division. Okay, so what do I do? My professors, are you there? Which one is supposed to be here? Is it s squared minus 3s plus 2?
Yes, sir.
Okay,
Yes, sir.
so that is supposed to be here. Okay, then you do this. And here, per experience, you know that you have to leave a line before so that your quotient will take that line. So in effect, you wouldn't have any line left unattended to. So at this point, this must be written here, but I will write it in its expanded form completely. So that will give me s squared. There is no s term, so I introduce 0x, then plus what? 1. Okay, then we kickstart our long division after setup. So s squared over s squared, that will give us what? 1. Okay, so we are going to write 1 here. Then you come and multiply the whole of this by 1. So that will give us, okay, am I right? Okay, so that will give us s squared
Yes, sir.
minus 3x, okay, plus 2. So this we now come and subtract. Okay, so what do we do if you subtract? Always your first will go, it will be 0. So this will give you positive 4x, then minus what? 1. Okay, if you subtract 1 minus 2 will give you minus 1. Okay, at this point we can stop, right? Because the degree of your new dividend is less than that of the divisor. So it means your new dividend becomes the remainder. So at this point, we can now write our polynomial as a sum, our rational function as a sum of a polynomial and what? A proper rational function. So I will say that what I have here again will be equal to, okay, my quotient, what's my quotient? 1 plus my remainder, what is my remainder? 4x minus 1 all over my divisor. And what is my divisor? My divisor is s squared minus 3x, okay, plus 2. All correct, my professors? Okay, somebody
Yes,
said 3x. Please,
yes, sir. Please, 3x.
what is 3x?
Sir, please, the negative becomes positive, and
Which
then
one? Oh,
zero.
okay, which one? Which one?
When you are subtracting the x squared minus 3x plus 2,
S
it's
squared. Okay,
3x.
this one, the minus that. It will give
Yes,
us,
sir.
so it will give you positive. Oh, it will be positive
Yeah,
3x.
3.
Oh,
Yes, please.
what happened? Why did I write 4? Okay, thanks for drawing my. So this will be 3. So at that point, you are doomed. Okay, so it means once your identity is wrong, okay, so take your time and get it right. So what did I do? How did I write 4? Okay, anyway, so let me clear that. Okay, so thanks for drawing my attention to that. This wasn't my usual trick. Okay, so I was going to write 4 again. Oh. So 3, okay, 3. Okay, so you've done the change. Is that not it? Okay, so this is going to be 8. So at this point, okay, remember you said we have to take this part and go and what? Write the identity, then we come and attach to that. So it means here, because you are going to take this part, you cannot write equal to and come and deal with only this part. So you have to write in math anytime you are taking a portion of whatever you are given to work with, especially if you want to write equal to. Equal to is a very sensitive, okay, symbol or sign. So take note. So in this case, we are going to write taking. And which one are you taking? You are taking the proper side, which is the remainder over the divisor. So 3x minus 1 all over, okay, x squared minus 3x plus 2. So we are going to now write the identity of this, then resolve. After getting the resolution of this, we come and add it to the one, and that will give us our overall resolution. So at this point, I know this will be equal to, before I resolve, I have to check whether my denominator is factorable. And here we can all see that it's factorable, so I cannot write the identity straight away. Okay, so my numerator will be 3x minus 1, all over my denominator here. A special situation, quadratic, is 1, so you can factorize straight away without going through the grouping. So it will be x, one bracket, then x, another bracket. You go and look for the factor pair. So factor pair of positive 2, that when you multiply, you get positive 2. When you add, you get negative 3. And that will be negative 2 and negative 1. Am I right?
Yes.
So
Yes,
I'll come and write negative 1 here, negative 2, or negative 2, negative 1. You can. Otherwise, if you want to do the grouping, come and do that as your rough work. Take notes. So at this point, I can write the identity of this, what I've taken. So I can come and write this is identical to, I'm going to introduce, linear factors. So 2 of them. So I'm going to have 2 fractions for, the identity of that. So that will give me a over my first linear factor, which is x minus 1. Then plus b over my second linear factor, which is x minus 2. All correct, my professors?
yes, please.
Okay,
Yes.
so at this point, I could have even allowed you to do it, then we'll continue. So what is the next step? You write this as a single fraction. Okay, so remember where we are coming from. So as a single fraction, your denominator, please, use this so that you can easily identify. Or if you want to use this, it's about to go by the factor. So I will use x minus 1, into x minus 2. Okay, so in this case, this will go into my denominator here, x minus 2 times a. So I will get a into x minus 2. Then plus, this will go into this x minus 1 times, then times b. So b, b into x minus 1. All correct, my professors?
Yes, sir.
Okay, so at this point, what do? We now come and equate the numerators. So what do we have as our numerator there? 3x minus 1 should be equal to the numerator here. So a into x minus 2, plus b into x minus 1. Okay, let me write my b well. It's looking like 13. Okay. All right, so at this point, what do? We have 2 linear factors. We thank God. So cover up would be best. So if x is equal to, which one? I will go for 1. Because that's a smaller value. I always want to do the easy one first. So 1, if I use this factor, so x is equal to 1, I am going to get what? 3 into 1 minus 1 is equal to a into what? Into 1 minus 2 plus b into 1 minus 1. Which will give us 3 times 1 is 3 minus 1. So that will give us 2. Is equal to, this will go, so minus a. So I'm going to get a to be equal to minus 2. All correct? Then
Yes, sir.
if x is equal to, which value do we go for? Positive 2. Our second one. So we are going to get 3 into positive 2 minus 1 will be equal to a into 2 minus 2 plus what? B into 2 minus 1. So which gives us 6 minus 1, which will give us 5 here, is equal to 2. So this will go. So 2 minus 1, so plus b. So I will get b here. So I know the values of a and what? And b. So in this case, please take note. All that we are doing basically means to an end. It is when you are ending that you conclude. So what do we have here? I can say that this implies, the resolution of what I have here, is what as you mature, you can straight away go and write the identity. So I will say that this implies that, my whatever I resolve, which is the 3x minus 1, all over my x squared minus 3x plus 2 will be equal to, okay, so what is A? A is negative. I cannot start with A. Okay, so I'm going to start with a B. However, here, I can advise you, if it is negative, okay, you can start with the negative because are you concluding with it? Are you?
No, please.
You are not,
No,
because
please.
what you are going to conclude with, which is this one, the first term is already positive. But I just want you to always be on guard. So I want it to be part of you. So that's the more reason why, again, I'm not going to start with the negative. Otherwise, it is that advice, okay, there's a situation that it doesn't hold. So what do I do? My A is negative, I won't start. My B is what? Positive. So I will start with that one. So it means I will use 5 over, okay, x minus 2, then minus my A is what? 2. So minus 2, so it will be 2 over then your x minus 1. Remember, I didn't write therefore here. This is only the partial fraction for this, but you were asked to write the partial fraction for what you have here. So if you know the partial fraction of this, you come and add it to what you have here and you are done. So at this point, I can have my conclusion drawn. So therefore, okay, the partial fraction of what? X squared plus 1 all over, okay, x squared, okay, minus 3x plus 2, okay, will be equal to, okay, remember we said 1 plus the partial fraction of formula, so it will be 1 plus whatever that you have here, which is 5 over x minus 2 over x minus 1. All correct, my professors?
Yes, please.
Okay, so with this one, the only
Yes.
addition is that perform your long division. Okay, write your rational function as what? A sum of your quotient plus what? An improper rational function. Your quotient will always be a polynomial. So in books, they won't write quotient plus, they will write polynomial plus. Okay, so this is a polynomial, it's a constant polynomial, it is. Okay, then plus your proper rational function. Then come and take your rational function, proper rational function, resolve, which we are all experts now. Okay, resolve your resolution that you had in your conclusion, attach it to the quotient, and that will be your final answer, as simple as that. So if that's the case, okay, if you don't have any question, then we'll move on to, okay, the next one. So the B, I'll walk you through. It's the same thing, only that, okay, what do you call it? Let me see. Okay, a few additions, that's all. Okay, but it's the same approach that we are going to, okay, deal with. So at this point, let's look at the B. This is what we are asked to resolve. First question, proper or improper? Degree of the numerator is 2. Degree of the denominator will be 2 as well. So proper. Once it's proper, I cannot, okay, write the identity straight away, or I cannot resolve straight away. So I have to go through the long division to get my polynomial plus what? The proper rational function. Take the proper and go in. So if you go through the long division, and you know that in long division, we cannot, okay, do our long division when you said your divisor, your dividend, they should be written out completely. Okay, take note, they should be written out completely, and also they should be written out in the standard form. So if you look at your numerator, it is written in the standard form, but it's not written out completely in decreasing powers of x, but not complete. There are missing terms that we need to introduce. But the denominator, obviously, we see product, so we have to expand. So that's informed, okay, that. So you expand this one and combine like term, but you do that as a rough work. Okay, if you can do it mentally, you do so. So it will be s times this, which will give you s squared. Then you come and multiply this x, and this times this will give you minus s. This times this will give you 2s. So they will be like terms. Minus s plus 2s. So that will give you your x. Then you come and multiply this and this, which will give you your negative 2. So after that, you perform your long division. So the expansion here basically was to help you do your long division. So your long division will give you your quotient. So this will be equal to quotient plus your remainder. And you can see that in this remainder, I had a negative first term followed by a positive. So when I was writing it here, maturely, I swapped for convenience sake. Is my point well made? Positive first followed by negative, always. Positive first followed by negative.
Yes, sir.
Okay, then you come in and you can see that here I didn't use this because I knew going forward I have to get the factors because I will be writing the identity. So I'll go back to the factorization. So instead of writing this, I use the factorized form of that, which is allowed. The expansion was to help you deal with what the long division, like I said. So you come and take this as usual, like I said. Okay, write the identity of that. Okay, after that, you go and resolve. So you know how to do that. Okay, you equate the exponents here, the linear factors plus 2s plus 2s minus 1. So obviously, because I move in this order, I did the minus 2 followed by 1, but it doesn't really matter. You can do 1 followed by the minus 2. Okay, to be the same volume of work. You come and do that. You get A to be equal to negative 3. Okay, then B going forward, that is what will give you. So B will be equal to what? Will be equal to 1. So at this point, as you mature, you can straight away move from here to this. Because I can come and once I know my A and B, I know the resolution of whatever I took out. I'm talking about this. I know the resolution of this. So I'll go and write, you see, therefore, whatever that I was asked to resolve is equal to 2 plus the resolution of this that I had there. Then I go and use this one, okay, to get the resolution. Let me write this one well. Okay, so the plus is not looking like a plus. Well, okay. So at this point, however, please take note
Minus.
here. You don't write therefore, take notes. You don't write therefore here. Okay, because this is only a means to an end. So if you want to write this, don't write therefore. Okay, so the therefore will be where you are concluding for whatever that's directly were asked to find. So 2 plus, then you attach that. Is my point well made? Hello, my professors. Is my point well made?
Yes, sir.
Okay, no questions at this point. Can we proceed?
Yes, please.
All right. Okay, so I'm taking him as your spokesperson. Otherwise, okay, you talk. Okay, so now, oops, what happened? I didn't bring the C. Okay, no problem. I will do that. Okay, so quickly give me some few seconds, then let me take care of the C. Okay, so now let's look at the C together. Ordinarily, we were not supposed to look at C because it's in red. Okay, but because I told you that this was the question that came in your assignment, and I promise you that we'll look at it in terms of what the improper, okay, the identity way. Okay, so that in case maybe you don't want to use, though I have indirectly compelled you to use that one, we want to see whether we will end up getting the same result or confirm whether indeed the first approach, which is the substitution approach, will be ideal in terms of saving time and space. Okay, so quickly, obviously we know what we have here is not what proper, it's improper. So it means we cannot, okay, resolve straight away. So at this point, what do? We are going to basically, okay, expand because we are going to do the long division. We need to expand the denominator. Okay, so we are going to get this to be equal to x squared. So you can see that I didn't write the identity because I cannot write the identity. I'm not introducing any letters. So if you expand this, you know binomial squared. You should know how to expand this. So it will be a squared, which is s squared. Okay, plus twice the product of this. So that will give you 4x. Okay, then plus 2 squared, which is 4. Okay, so at this point, you come and set up your long division and you kickstart your process. So I am setting up. Okay, your numerator, okay, is not written out completely. So your dividend, so you have to do that here. S squared plus 0x plus 1, just as we did in the other situation. So S squared over S squared will give you 1. You come and write it on top of the term in the dividend with the same degree. Then, okay, come and multiply. So that will also give you S squared, okay, plus 4x, okay, then plus 4. Okay, this time I'm going to be very careful subtracting. Okay, so in this case, what do we have? Okay, this will always go. So this will give us minus 4x. Okay, then this will give us minus 3. All correct.
Yes, sir.
Okay, so look at what is going to happen. So in this case, this becomes our new dividend, degree less than this. So the new dividend becomes your remainder because its degree is lower than that of the divisor. So I will say that whatever I have there will be equal to my quotient, which is 1, plus my remainder. Okay, and my remainder, okay, minus 4x, okay, minus 3 all over my divisor, and the divisor I am going to use the factorized version of the divisor because I will resolve. Okay, I'll write the identity. All correct. It's my point well made,
Yes.
my professors. Okay, here someone can equally come and write minus, someone can write it this way, 1 minus. If you bring the minus out, then your numerator on the fraction will be all positive terms. Do you agree? So that the negative is affecting all the terms there. It's my point well made. But let's stick to what we have here. We won't change because we will take, this is not our conclusion. If it's our conclusion, we would have factored out the negative and changed this one to negative. So there's still a means to an end. So we are going to deal with it our usual way. So come and take. So taking, and you need to write that. Okay, taking minus 4 x minus 3 all over x plus 2 all squared. Okay, we know we are going to write the identity. This will be identical to repeated factor. Okay, so and your repeated factor is linear. So it will be 2 fractions a over your repeated factor s plus 2, then plus b over your repeated factor squared. Is my point well made, my professors? Hello, all correct? All correct.
Yes,
Yes.
please.
So now, even where we've gotten to at this point, you can even know and you can say for sure that what we have here is more involving than the other one. If we were using the substitution method by now, you would have been done. You get my point?
Yes.
Okay, so that's why you have to be very careful in terms of how you use your time. So at this point, single fraction all the way. So you take your LCM. Okay, your denominator will be s plus 2 all squared. I've told you without struggle, come and look at your denominator there. So this will go into this s plus 2 times a. So you get a into s plus 2 plus b. This will go into this what? 1. So plus b. You end there. So now what do? Equate the numerator. So this implies that the numerator minus 4x, okay, minus 3 should be equal to, okay, your numerator here, which is a into x plus what? Plus 2, then plus what? Your b. Okay, so at this point, you are in a comfortable lead. Your first linear factor, okay, or your repeated linear factor, that's the one that you can consider. So if x is equal to negative 2, okay, comma, you get minus 4 into negative 2 minus 3. That should be equal to a into negative 2 plus 2, then plus b. Okay, so in effect, this will give you 8 minus 3, which will give you 5, and that is equal to b. So you can see that we are making headway. We had b 5 for, okay, the other one, you saw 5 somewhere over. So you can go and compare anyway. So the second one, now you've exhausted, okay, your possible substitution from the question itself. So let's go to our liberty values. So which value do we go for? Hello?
0.
0, very good. Okay, so that will give us, if x equal to 0, you get minus 4 into 0, then minus 3 is equal to a into 0 plus 2, then plus b. Okay, so in effect, this will give us 0, so minus 3, okay, will be equal to, this will be 2a. Am I right? Let's check well. Am I?
No, please.
Okay, so what is wrong?
Plus B.
Plus b, be very careful. Okay, you knew, okay, all of them would not go, then you go and substitute. So And now this implies that we substitute, we know the b. So minus 3 is equal to 2a, okay, plus b, and b is 5. So you now move this one to this side. So that will give you minus 3 minus what? Minus 5, which will give us 2a is equal to, okay, minus 8. Do you agree?
Yes, sir.
Okay, you write it
Yes.
again before you divide. Don't forget. And you can see that anytime I'm writing, I push my work here so that if need be and I need to do a rough work, I will have room for that. So at this point, okay, I am going to move on to the next page. Okay, so if you continue, what are we going to get? So you know we get a to be equal to what? Negative 4. So we are going to write that. So a will be equal to what? Negative 4. Now we know the values of a and b. So I can say that this implies that, remember I'm not drawing my conclusion, or let me even, okay, draw the conclusion the matured way so that you also know. Because what you are going to write there usually will not carry any marks. Even if there will be a marks there, if you skip and you move it, it will be given to the last step that we are going to, okay, deal with. So let me equally do that. So now that I know the a and b, I know my resolution, sort of. So I will go and draw my conclusion. Therefore, okay, what I was asked to resolve, which is x squared plus 1 all over, okay, x plus 2 all squared, okay, will be equal to, remember when you perform the long division, okay, our quotient was 1, so we are going to write it. So it will be 1, okay, then plus, okay, let me see whether all of them will be, I have negative here. Did I get any positive value? Yes. So by here, I've told you that doesn't really matter. So at this point, because my first term, I have written my first term already is positive. So my second term, whether it's negative or not, I don't mind. Okay, so I'm going for my second term, which becomes the first term of your resolution there. So in this case, my, okay, where is it? Okay, my A gave us what? Negative, okay, 4. So I'm going to write it. So, and B gave us what? 5. So I'm going to get minus 4 over, okay, what do we have? We said over, what was the, okay, that was S plus 2. Okay, then the other one was plus 5. So plus 5 over x plus 2, okay, all squared. Is my point well made, my professors?
Yes, sir.
Okay, so now
Yes, sir.
let's go back and verify. So quickly, okay, we'll go back and see whether or we ended up getting the same result. Okay, so let's see. Are they not the same? The substitution approach. So you can see that even this one full, okay, slide, we couldn't exhaust it. The other one, we exhausted one and went, okay, to even create another one. So obviously, this should tell you that the substitution method will be what? Ideal. So take notes of that. Okay, and that one will be ideal when there is only one repeated factor in the denominator, no other factor attached. Okay, so this will be it for, okay, the lesson 4 of rational functions and partial fractions. In our next lesson, we are going to make use of all that we've learned so far in solving selected past questions or likely exams questions. So at this point, any questions before I finally bring the curtains down? Any questions? Okay, so we thank God. Okay, so once again, thank you very much for making the class a success. Okay, your contribution, everything, okay, very much cherished. God bless us all.